Oh, well. Well, we mainly talked about curriculum in fluid mechanics. We first tried to answer how we can make space or time for additional topics that could be chosen by the interest of the instructor. It could be influenced by research interests. And we honestly didn't come to a conclusion. We did not think that if you take a typical curriculum where you have 3 context hours in a lecture plus maybe a lab, maybe not, we did not find any topics that consistently could be removed from the curriculum to make space. We then went on to the more hypothetical question, what if you had time, or what if you have the luxury of having a tech elective maybe in the senior year, what kind of topics would you cover? And I think one of the topics that came up relatively quickly, and there was some sort of consensus, was CFD, to teach something computational in fluid mechanics. First, because it gives the students a background that helps them to go out into industry. CFD tools are in use. And second, it provides some sort of a playground. It's very easy to take a problem that cannot be analyzed in the typical classroom analytical style and just play around with it and thereby learn more and convey more about the physics of fluid mechanics.
Okay, thanks. How about this table?
Want me to say? Okay.
Oh,
All right. I'll need help probably. Well, we also discussed the curriculum and how we can make room for new things, and at the same time, what would have to go. That led to an interesting discussion about pipe flow.
Could you turn around to everybody?
Yeah.
That led to an interesting discussion about pipe flow, with some people believing that it was maybe too dull to stay in the curriculum, whereas other people believe that it was connected to lots of other important concepts and was a way to introduce a lot of everyday experiences. We also discussed the fact that depending on the curriculum, whether it's engineering, physics, chemical versus mechanical engineering, students may or may not see some nice everyday concepts like surface tension. There was general agreement that including things like CFD would be important, so that there is a need to introduce this. We also discussed quite a bit different approaches to how to introduce basic concepts in fluids, like the idea of vorticity. And we spent quite a bit of time talking about materials used in teaching these courses, from textbooks to supplemental materials such as multimedia fluid mechanics, DVD.
I would add that the problem of curricular compression is very different depending on whether you're teaching in an engineering course or a math or physics course. In the latter case, it often isn't, the competition is not between different topics in fluid mechanics. The competition is between having any fluid mechanics and doing the normal material. It's a very different problem.
Okay, thanks. How about this table?
We didn't talk.
You didn't talk.
Now, we ate. We kind of started on the bottom up. Or, I don't know why.
That's good.
We were talking about large classes and stuff like that. I guess the one idea that is a general, was considered a good idea around this table is something I stole from you, which is in my undergraduate fluids class. We're doing a flow visualization project where it's a service class, so there's a tremendous variety of interest in the class, and trying to get them to tie something into the real world that they see that piques their interest, and then to use some physics, something to describe it, and talk about it. So trying to make it a little more personal in a large setting, in a large undergraduate setting.
Okay.
All right, I lied. We did talk.
Is it just one project or several visualization projects?
One. Just through the semester, they have to take a picture. The rules are they have to take a picture themselves. So I don't want them downloading anything. It can be anything they want as long as there's some fluid moving in it, and they have to use something to describe what's going on. Buckingham Pi to talk about what are important parameters in it, estimation of force. I don't care. Just something that they find interesting and that they can relate some physics to.
And this was in the context of a regular fluids curriculum in other ways.
Yeah, I guess it's trying to make it personal and trying to make it relevant to a wide variety of students who may or may not be interested in what we're actually doing.
Okay,
We
great.
spent a lot of time talking about exams too, how to make good exams, homework.
Yeah. And yeah, how do you do that?
We talked about some of the extra project, well, like if you find a mistake in the textbook that's not on the errata sheet, you assign that as a homework problem to have the students find the mistake. Make their own exams and compare with other people, have other students take it, talked about that. Other types of little projects, making demos and things like that. There's a lot of things you can do to make interesting homework problems.
Okay.
All right, I think we'll add to the question number 2. We had a lot of discussion on that, and it was about how today's graduate students are different. And a lot of it came with actually the undergraduate preparation for the graduate students and what we should do about that. And one thing we talked a lot about was we thought that the students were observationally impaired. They spend so much time looking at a computer screen that they don't look around them. And so they don't have visualization skills, they don't understand things we speak about in 3 dimensions or just normal things. They don't understand the description, how to get out of that. And so any ways, including this FlowViz project, we talked about that also, any way that you can get them to look away from the screen and think about things differently that way through laboratory exercises and such. The other thing was to try to incorporate some programming skills, such as MATLAB, into the undergraduate curriculum to have that, so it's a capability that graduate students have. And even our table felt that MATLAB was sufficient as long as you used it in a programming mode,
Right.
that they didn't have to go any beyond that.
Yeah, we talked about that at our table as well.
And also we felt that they very much rely on template matching to solve problems. And again, we just discussed it. I don't know that we came up with ideas so much, but how frustrating it is that they can't, the critical thinking skills needed to always trying to find the right template. And so if there's ideas that you could prepare them better for this, but this is what the feeling of graduate students and even undergraduates came.